Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology, and Autonomous Institution, Coimbatore. In this YouTube video, I am going to discuss the 19 ECB 301 Analog and Digital Communication subject under the topic Pulse Amplitude Modulation. So, based on my previous YouTube video, you have some knowledge about what is in by communication and what is in by modulation, various types of modulation, and what is the purpose of amplitude modulation and the classifications of amplitude modulation, all are discussed. Now I am going to discuss the pulse communication. Pulse communication refers to a category of modulation techniques where information is transmitted using a series of pulses which can vary in different properties such as amplitude, width, position, or code. These techniques are fundamental in digital communication systems and are essential for converting analog signal into digital. Key types of pulse communications are pulse amplitude modulation, pulse width modulation, pulse position modulation. Pulse amplitude modulation is a key modulation technique used in digital communication for transmitting analog data and is one of the most widely used type of ADC, that is analog to digital conversion. It's a process is simple where amplitude of a sequence of pulses changes with the instantaneous amplitude of the analog message signal. The analog signal that is to be modulated is sampled by a sequence of pulses that are amplitude modulated on the carrier to produce the amplitude modulated pulses. It is similar to the process of AM wave. This figure shows the pulse amplitude modulated waveform. First one shows the message signal, second one is the carrier signal, and the last one is the amplitude modulated carrier signal. This is the PAM block diagram. Pulse amplitude modulation is a modulation technique where amplitude of a series of pulses is varied according to the amplitude of analog signal being transmitted. There are three important blocks in pulse amplitude. First one is the sampled, second one is the quantization, and the third one is the modulation. And fourth one is the transmission through a medium of transmission, reception, reconstruction, and pass-through filtering. So all these steps are used to convert a original analog sine wave into a converted discrete pulses of waveform. So these pulses of waveform is the major sources in converting an analog signal into digital signal. First process is sampled. Periodically the analog signals are sampled. These are called sampling intervals, and an aliasing of this has no chance if you put a condition of the sampling rate. The important criteria, Nyquist's theorem states that the sampling frequency must at least be twice the highest frequency component of the signal. Quantization. Each sample is provided with quantized amplitude. Modulation. Since each sample quantization level constitutes the amplitude of the generated pulses, only single pulses are produced if every sample level is integer. Often the pulse doesn't change its width, but its amplitude can adapt any one of the quantified sampled values. Transmitted through the medium of transmission. The carrier, for example, is a visual analog signal or a digital one, is represented as the pulse train that is modulated. It can be transmitted through wireless or wired pathway depending on the framework of purpose that lies behind it. Reception. The reception results in amplitudes modulation, which then undergoes a process of demodulation. Reconstruction. By the summation of different orders of the magnitude outlined in a given position, the low frequency are undermodulated and the final rebuilt into a continuous signal. Pass-through filtering. A low-pass filter is generally employed to take out the highest frequency components from the smooth recovered analog signal, which meanwhile preserves the original analog signal component. This is the demodulation of pulse amplitude signal. Extracting original data from the modulating signal is the demodulation process of pulse amplitude modulation. So some of the applications of PAM are it is used to send digital data over phone lines digital subscriber lines modems using PAM. Pulse code modulation is used in audio CDs to encode analog audio signals into digital form. Digital data is sent across optical fibers using PAM in fiber optic communications. Psychological signs are sent over PAM in biomedical signal processing, including electrocardiography. Pulse width modulation techniques are used in PAM based industrial automation system to control motor speed and position. So, in this YouTube video, I will discuss the what is meant by pulse amplitude modulation, how the pulse amplitude modulation is generated by using of carrier signal and message signal. Also, I discussed the pulse amplitude of demodulated signal. So, thank you for watching my video.